Good evening, one and all. Today, in this live lecture, we shall discuss the Laplace transformation of some typical functions. In the last lecture, we have seen what is meant by the Laplace transformation. But in this today's lecture, we shall discuss the Laplace transformation of some typical functions. Now, which are those? How to calculate the Laplace transformation of typical function? Now we shall discuss this. Students, are you hear me? आवाज येतो का रे? तर Laplace transformation of a typical function. In that typical function, we have to start what is mean by. First of all, again I shall revise the concept regarding the Laplace transformation. 1 minute. So, in the last lecture we have seen, actually this is the first unit. In that first unit, this is the second part. In the last lecture, we have seen the Laplace transformation and its concept regarding the basic concept, introduction, integral transformation. But today in this lecture, we shall discuss Laplace transformation of some typical function. Before starting the Laplace transformation of some typical function, we have to discuss or we have to revise what is meant by the integral transform. The basic definition for the integral transform is capital F of x is equals to integral from minus infinity to plus infinity k of s comma t into small f of t dt. Here in this case, k is called as the kernel of the transformation and f of t is the given function and capital F of s is called as a transformed function. Now, by the proper choice of functions, kernel, we can take different types of transformations. So if we consider the kernel which is of the type k of s comma t, which is equals to 0 if t is less than 0, or k of s comma t which is equals to e raised to minus st, if t is greater than or equals to 0, then the resulting transformation is called as a Laplace transformation. And see this Laplace transformation we can write in the form of a convenient letter, that is in the form of a p also here. So we can write this Laplace transformation in the form of also p L of f of t which is equals to f of p. We can use in place of s as a f of capital F of p. P is the complex. P may be complex, real or complex. Integral from 0 to infinity e raised to minus pt into f of t dt. So this is also Laplace transformation for the function. Okay, Laplace transformation for the function. Now here you must know the Laplace transformation of a many function can be obtained by routine formal integration of a definite integral function. By using this formula, we can obtain, by integrating this, we can obtain the Laplace transformation. Here we can treat p as a real or complex. Real or complex, that means we can take p. P here in this case, if p is a complex, 1 minute, then this is the real part of p and this is the imaginary part of p. Imaginary part of p on the quadrantal system. Okay, so we can represent this as a c. Suppose this is a complex c plus I infinity, c minus I infinity. So this can be written as this part is called as a c. Whatever may be, okay, it is not necessary to write this. Now our aim is to find, today our lecture's aim is to find the Laplace transformation of some typical functions. But before starting the Laplace transformation of typical functions, you must know some special functions. You must know the basic definition of the gamma function. You know that. फक्त यहाँ पे आपको गामा फंक्शन की बेसिक डेफिनेशंस आपको पता होना चाहिए, इसलिए बिफोर स्टार्टिंग द Laplace transform, how to calculate the Laplace transformation of some typical function, you must know the gamma function. Gamma of n is equals to integral from 0 to infinity e raised to x into x raised to n minus 1 dx. This is the gamma function, gamma of n. So you must know the definition of the gamma function. We can write in the form of x, in the form of y. Also, there are some properties, basic properties you must know, because these properties we need to find the Laplace transformation of some typical functions. So, 1 minute. Okay. आवाज येतो का रे सर्वांना? काही अडचण आहे का? 1 minute. एक मिनिट रे, ठीक आहे. आवाज येतो ना सर्वांना? तर ठीक आहे. यू मस्ट नो द गामा फंक्शन, प्रॉपर्टीज ऑफ गामा फंक्शन. गामा ऑफ n plus 1 is equals to n into gamma n. The definition of the gamma function, gamma n is equals to integral from 0 to infinity e raised to minus x into x raised to n minus 1 dx. n must be positive. Then see this. Okay. Gamma of n, we can write n minus 1 factorial, because these basic properties you need to prove some Laplace transformation of the typical function. So I am going to revise this gamma function here. There are different properties of a gamma function, but beta function, but we need some basic properties of the gamma function. Now see here, students. Now we have to start how to find out the Laplace transformation of a typical function. In the last lecture, we have already find the Laplace transformation of e raised to at. Okay? We have, in the last lecture, we have already seen how to find out the Laplace transformation of e raised to at. Now, today we shall discuss the second function, that is f of t. 1 minute. Second typical function, we have to find out the Laplace, find the Laplace transformation of, find the Laplace transformation of f of t is equals to 1. Okay. Actually, we have to find out the Laplace transformation of f of t is equals to 1. So, how we can find the Laplace transformation of f of t is equals to 1? Again, we have to use the basic definition of the Laplace transformation. See here. Okay. Now, actually, what is the formula, or what is the basic definition of the Laplace transformation? L of f of t, or we can also write capital F of p, which is equals to integral from 0 to infinity e raised to minus pt into f of t dt. Actually, we have to find out the Laplace transformation of function f of t is equals to 1. Suppose this is the constant function. F of t is equals to 1 is called as a constant function. Now our aim is to find out the Laplace transformation of this constant function. How we can find the Laplace transformation of the constant function? We have to use the definition of a Laplace transformation, that is capital F of t is equals to integral from 0 to infinity e raised to minus pt into f of t dt. Now replace the value of actually solution of this integral, solution of this definite integral, which gives the value of a Laplace transformation of f of t is equals to 1. So now we can solve this step by step. Integral from 0 to infinity e raised to minus pt into f of t dt means 1. That means 1 into e raised to minus pt, we can write integral from 0 to infinity e raised to minus pt into dt. Now who can tell me what is the integration of e raised to minus pt? This is the simple integration. So integration of e raised to minus pt. कोण आहे रे ऑनलाईन असतील तर ते विद्यार्थी सांगा. फर्स्ट इंटिग्रेशन सांगायचं. Now you tell me integration e raised to minus pt. Integration of e raised to f of x is e raised to f of x. Again divide by derivative of f dash of x. So e raised to minus pt च integration e raised to minus pt divided by minus p. Okay, now see here, this is the definite integral, so its lower limit is 0, its upper limit is infinity. Now again we have to solve this. Minus p is the constant term regarding this, because this is the integration with respect to t. So as per this integration, these limits are for only t, so treat p as a constant. So we can write this as which is equals to minus 1 upon p integral e raised to minus pt over the limit 0 to infinity. If we put the upper limit minus 1 upon p, if we put upper limit e raised to minus pt in place of t, keep infinity e raised to minus infinity, means 1 upon e raised to infinity. See this, yesterday I have explained this. E raised to, this is the approximate value, see this, e raised to minus pt, that means which is approximate equals to e raised to minus p into infinity. That means 1 upon e raised to infinity. P into infinity means infinity, and e raised to infinity means which tends to infinite value, so which is equals to 1 upon infinity. Note that this infinity is not a real number, but I am telling approximate value. This is the solution process, then which goes to 0, which goes to 1 upon infinity. As n tends to infinity, then 1 upon n tends to 0. Actually the formula limit n tends to infinity, then 1 upon n tends to 0. Actually infinity is not real number, so this is the concept regarding this. So we can find the value of this term. 1 minute. Okay, ठीक है, calculate करा. 0 minus, again put the value of e raised to upper limit 0, e raised to minus 0, e raised to 0, e raised to 0 is 1. So that can be written as a 1 upon p. Therefore we can write Laplace transformation of f of t means 1, f of t, which is equals to capital F of p, which is equals to 1 upon p. Is it okay? समजलं का हे सर्वांना? पहा, व्हेरी गुड. माधव केंद्रे, ठीक आहे, माधव केंद्रे, आवाज येतो का रे? यस, ओके. काय अडचण आली तर विचारत चला. मी प्रत्येक प्रॉब्लेम्स अत्यंत स्लोली व्यवस्थित घेणार आहे. Okay, now see this, we shall move towards the second typical function. This is the Laplace transformation. This is the Laplace transformation of a given function f of t is equals to 1. Now we shall move towards the third definition, third problem. Third, find the Laplace transformation of of f of t is equals to sin at. F of t is equals to sin at. Now how we can find the Laplace transformation of f of t is equals to sin at? Now we have, according to the definition of the Laplace transformation, capital F of p, which is equals to integral from 0 to infinity e raised to minus pt into f of t dt. Is it okay? Now we can find the value, replace the value f of t. What is the value of f of t? Integral from 0 to infinity e raised to minus pt into f of t means sin at. That can be written as, actually याचा हा फॉर्म्युला तयार होतो e raised to pt into sin at dt. Because here we have to find out the Laplace transformation of f of t is equals to sin at. Here we have to use the formula. आता इथं मात्र तुम्हाला ऍक्च्युअली डायरेक्ट फॉर्म्युला वापरायचे. तो फॉर्म्युला तुम्हाला समजून सांगतो अगोदर. ऍक्च्युअली we know that, what we know that, we know that the formula for, here we know that, नसेल तर मी समजून, I shall explain that formula. Integral of e raised to ax into sin bx. This formula which we have to use. Integration of e raised to ax into sin bx. Actually, this is the integration. Then the value of this integral is e raised to ax divided by a square plus b square into a sin bx minus b into cos bx. This formula which we have to use. Actually, student, to solve this problem, to calculate the integral of this function, we have to use this formula. We have to use this formula. आता तुम्हाला असं वाटू शकेल की how we can get this formula? I shall solve this. Now suppose let I is equals to, first of all I give the proof of this formula, how we can get this formula, then we shall move towards our main problem. So I is equals to, suppose integral from integration of e raised to ax into sin bx. But according to, here we have to use the integration by part rule. We have to use integration by part rule. Here dx. Say this dx. Here we have to use the integration by part rule. But before using the integration by part rule, we have to follow the priority of function according to the Lect. You know what is mean by Lect? Lect म्हणजे काय असतं? L म्हणजे कुठला फंक्शन असतो रे स्टुडंट? You tell me. Before using the by part rule, we have to follow the priority of the function according to the Lect rule. Lect means, L means the logarithmic function, I means inverse trigonometric function, A means algebraic function, T means trigonometric function, and E means exponential function. Already we have seen this concept in the UG program also, but I am going to solve these terms one by one. First of all, I am going to give you the proof of this formula. Integration of e raised to ax into sin bx is equals to e raised to ax divided by a square plus b square into a sin bx minus b cos bx. So before, how we can get this formula? Then we have to use, here e raised to ax is exponential function, sin bx is a trigonometric function according to the Lect rule. According to the Lect rule, we have to write first trigonometric and then exponential. So we can write sin bx into e raised to ax dx. Now use the integration by part. You know What is the integral? बराबर है शिल्पा पंचा प्रणवती कदम. Now we have to use integration by part. First is it is sin bx. Integration of second. First term means sin bx. Integration of second means e raised to ax divided by a minus in integration. This is the integration by part rule. So derivative of first. What is the derivative of sin bx? B cos bx. Derivative of first, integration of second, e raised to ax integration e raised to ax divided by a dx. So we can write this. How we can write this? E raised to ax into sin bx divided by a minus b by a integration of cos x into e raised to ax dx. Okay. Now again we have to use the integration by part rule here. So what will happen here? I is equals to, we can write this term as it is, e raised to ax into sin bx divided by a minus, again we have to write b by a. Now integration by part of this function. First as it is integration of second means cos, here cos bx. Cos bx. So we can write this first as it is cos bx integration of second, again integration of e raised to ax is e raised to ax divided by a minus in integration, again derivative of first cos bx. What is the derivative of cos bx? Who can tell me? Derivative of first means minus b sin bx into integration of second. Integration of second means again e raised to x का integration e raised to ax divided by a into dx. चला रे प्रत्येकाने रिप्लाय करा, चला आन्सर देत चला. So I can write I is equals to e raised to ax into sin bx divided by a minus, we can multiply this b cos bx into e raised to ax divided by a square minus, again minus b by a, b square divided by a square, triple minus into minus, this b into this b, we can multiply this, b into b square, a into a means a square, integration of sin bx into e raised to ax dx. Is it okay? Now this integral is the repeated integral. Actually main integral is e raised to ax into sin bx dx, we can replace by I because we will get the repeated integral. This repeated integral we can replace by I is equals to integration of e raised to ax in sin bx divided by a minus b into cos bx into e raised to ax divided by a square minus b square divided by a square into repeated part of integral. This is the repeated integral, so we can keep it as a I. Now okay, बरोबर है शिल्पा पंचा. Okay, now replace this I towards I, so we can write I is equals to, how we can write I is equals to, sorry, I, again this, the part of I we can take on left side, so b square divided by a square into I which is equals to, we can take e raised to ax common. So the remaining term is sin bx divided by a minus b cos bx divided by a square. Is it okay? समजते का रे स्टूडेंट? काही अडचण आली तर विचारा. Now you can take the LCM on the left side. LCM काढल्यानंतर कसं होतं पहा, आय कॉमन काढा, म्हणजे LCM काढल्यानंतर असं होतं इथं a स्क्वेअर प्लस बी स्क्वेअर डिवाइड बाय a स्क्वेअर into I, which is equals to, keep this as it is. Now we can find the value of I. So I is equals to, take this part, a square plus b square on right side, so it will be a square divided by a square plus b square into e raised to ax. The remaining terms in the bracket as it is, sin bx divided by a sin bx divided by a minus b cos bx divided by a square. Now you can multiply by a square in the bracket. Then we will get the final result. I is equals to e raised to ax divided by a square plus b square, then a square into sin bx divided by a, that will be a sin bx, minus, again if we multiply by a square to the second term, then will be b cos bx. Okay, so we get the final result, that is a main formula, integration of e raised to ax into sin bx with respect to x, which will be e raised to ax divided by a square plus b square into a sin bx minus b cos bx. So this formula we have to use. This formula we have to use to prove the Laplace transformation. Actually, we have to use this formula. But I have given the different steps here. How we get this formula? Basic formula. Actually, we have to prove this. We have to use this formula to prove the Laplace transformation of some typical functions. What is the typical function? F of t is equals to sin at, whatever may be. So this formula is essential to prove the concept here. To prove this, we have to need the formula. What is that formula? परत एकदा मी formula लिहितो. We have, what is that formula? Integral e raised to ax into sin bx dx, which is equals to e raised to ax divided by a square plus b square into a sin bx minus b cos bx. Actually, this formula already we have proved. But we need only the formula, this formula. Now, so our this Laplace transformation f of p becomes integral from 0 to infinity. Now see this, compare this. A means we have to replace minus p, and b means we have to replace as a in the expansion formula. So we can remove this. Okay, not necessary to write this again. Now we have to use this e raised to, actually a means minus p minus pt divided by a square plus b square. A means minus p square, that means p square, plus b means a square, in a bracket, again a means minus p sin bt, b means a, minus, again b means what, a cos bt. This is the direct integration we have obtained from this formula. हे जे इंटिग्रेशन आहे ते डायरेक्ट आपण घेतलेलं आहे या फॉर्म्युल्यानुसार. काय अडचण आहे का रे? काय अडचण आली तर विचारा तुम्ही, काही अडचण नाही, मी तुम्हाला बिंदास सर्व टर्म परत सांगतो. नाउ वी हॅव टू रिप्लेस द लिमिट्स ऑफ इंटिग्रल फ्रॉम 0 to infinity. Again see this, we have to use this formula. By using this formula, integral e raised to ax into sin bx dx means e raised to ax divided by a square plus b square, a sin bx minus b cos bx. So our integral becomes a means minus p and b means a. We have to replace this. Then this Laplace transformation we will get f of p is equals to integral from this. Now our aim is to put the upper limit and lower limit. If we put this upper limit, so the value, if we put in place of t as a infinity, then you know that e raised to minus infinity, that goes to 0. This goes to 0, this first term goes to 0. So total term into remaining term means total term goes to 0. For upper limit, our total terms goes to 0. So f of p, which is equals to upper term, if we put the upper limit, then we will get the result as a 0. Now if we put the lower limit means we have to put t is equals to 0. If we put t is equals to 0 in the first term, then we will get this term, numerator e raised to 0 means 1 upon p square plus a square, into, again if we put 0, sin a into 0, sin 0 means 0, cos 0 means 1, sin 0 means 0, cos 0 means 1. So we can write this as, काय येईल पहा इथं, cos 0 means 0, so it will be, ठीक आहे, minus pt, okay, हे minus minus, it will be minus, ठेवा काय येतं पहा, sin 0 means 0 आणि minus sin cos 0 means 1 minus a. So we will get the result a divided by p square plus a square. So Laplace transformation of sin at, or we can write f of p, which is equals to a divided by p square plus q square. A divided by p square, sorry, q square is not here, a square. But note that here the real part of p, here is a very important real part of p. See this, तुम्हाला हे माहित पाहिजे, रियल पार्ट ऑफ p must be greater than 0. p is any complex number, we can write p is equals to c plus or minus I into infinity, whatever may be. So this is the Laplace transformation of sin at, which is equals to a divided by p square plus a square. This is the typical function, that is a sin at. Similarly, next we have to find out, note that to prove this formula, to find the Laplace transformation of f of t is equals to sin at, you must know the formula for the integral e raised to ax into sin bx. And already we have proved this formula also. You must know this formula. Okay. Now, fourth problem, we have to calculate this is the formula which we have proved. Actually, this is the formula. This is the formula which we have proved. तुम्हाला माहित पाहिजे फॉर्म्युला हा आपण इथं प्रूव्ह केलेला हा फॉर्म्युला कसा आला तो. ठीक आहे, याची गरज नाही, परंतु लॅपलास ट्रान्सफॉर्मेशन याच्याशिवाय रिझल्ट येऊ शकत नाही. वी कॅन फाइंड द व्हॅल्यू ऑफ लॅपलास ट्रान्सफॉर्म इफ यू डोंट नो दिस फॉर्म्युला. सो दिस इज द प्रूफ ऑफ दॅट फॉर्म्युला. Okay, now we shall move towards the fourth typical function. Find the Laplace transformation of f of t is equals to cos at. Same problem, we have already calculated the Laplace transformation of f of t is equals to sin at. Now we have to find out the Laplace transformation of f of t is equals to cos at. Again, write down the similar process. We have f of p is equals to integral from 0 to infinity e raised to minus pt into f of t dt. This is the Laplace transformation. We can find the solution of this integral. By using the solution of integral, we can find the Laplace transformation of f of t is equals to cos at. So replace this f of t integral from 0 to infinity e raised to minus pt. What is the value of f of t here? Student, इथं f of t म्हणजे काय सांगा रे? What is the value of f of t? आवाज येतो का रे? f of t means cos t dt. ठीक आहे, येतो ना आवाज? काय अडचण आहे का स्टुडंट्स? अडचण आली तर सांगत चला. ओके, नाउ अगेन हिअर वी हॅव टू यूज दिस इज f of p. नाउ यू मस्ट नो द फॉर्म्युला फॉर दिस. To solve this integral, definite integral, you must know the formula. So I am going to write here. We have same formula, integration of e raised to ax into cos bx dx, which is equals to same formula which we have to prove here, e raised to ax divided by a square into b square, a square sorry plus b square into a cos bt. हा फॉर्म्युला लिहा, a cos bx plus okay plus b sin bx plus b sin bx. Okay, so by using this formula we can write this integral in such a way. So f of p, capital F of p means Laplace transformation. Now keep this value e raised to, now we have to use the formula here, p means minus p means a, and cos, 1 minute, cos a. Here you have to write cos at. So to write this formula, we have to replace A means minus P and B means again A. So our main problem, our definite integral goes to the form, how we can write here, e raised to, now keep this value, minus A means minus Pt divided by P square plus A square in a bracket. Again we have to write A means minus P cos AX, again this B means A sin Bx plus again you have to keep the integral from 0 to infinity. So now we can replace this upper limit here in place of t. So e raised to minus pt, e raised to minus infinity, that goes to 0. So the total value of this function goes to 0 when we keep the limit as a infinity. Then minus, now lower limit we have to put. So for t is equals to 0, e raised to 0 means 1 divided by p square plus a square, again into, see this cos in place of okay, sorry, here we have to write t, either integration with respect to t, so here we have to write t. Now if we put the lower limit means cos t 0, cos 0, cos 0 is 1 means minus p into 1 means minus p plus sin 0 means 0. Is it okay, students? So the final answer will be p divided by p square plus q square. Sorry, p square plus a square. This is the Laplace transformation for cos t. So we can write Laplace transformation of cos at, which is equals to, we can write f of p, which is equals to p divided by p square plus a square. This is the Laplace transformation of, this is a typical type of a function. Again here the real part of p must be greater than 0. So thus we can find the solution of this, find the Laplace transformation of this typical function. That means here, students, up till we have seen the Laplace transformation of e raised to at, second Laplace transformation of 1, Laplace transformation of sin at, Laplace transformation of cos at. These are the elementary functions or typical functions for which we have already studied how to find out the Laplace transformation of these functions. समजलं का रे सर्वांना? हे चार फंक्शनचे लॅपलास ट्रान्सफॉर्मेशन कसे कॅल्क्युलेट केले हे समजले का? सी दिस फॉर्म्युला इज व्हेरी इम्पॉर्टंट टू फाइंड द लॅपलास ट्रान्सफॉर्मेशन ऑफ f of t is equals to sin at, f of t is equals to cos at. So this formula you must know, and already we have given the proof of this formula here. So note that the Laplace transformation of the given function already we have calculated. समजतं का रे? समजलं का? काय अडचण आहे का स्टुडंट्स? इफ यू हॅव एनी डाऊट देन यू कॅन आस्क मी. तुम्हाला जर कुठलीही डाऊट असेल तर विचारा. फायनल आन्सर ठीक आहे, लक्षात येतं का? ह्याच्यात काही समजलं नसेल तर विचारा रे. Laplace transformation of e raised to sin f of t is equals to sin at, f of t is equals to cos at. This is the formula, this is the reference formula you must know. Already I have given the proof of this formula, but there is not necessary to prove this formula. You must know only the formula, how we can write the integration of e raised to ax into sin bx dx. Okay, so these are the four typical functions. We have calculated the Laplace transformation of this typical function. There are again some functions. चला रे, प्रत्येकाने रिप्लाय द्यायचं म्हणजे मला लक्षात येतं की कोण ऑनलाईन आहे कोण नाही. त्यामुळं तुमचं रिप्लाय खूप महत्वाचं आहे. तुमचं रिप्लाय देणं खूप गरजेचं आहे. ठीक आहे, मी पाहत असतो. आन्सर येत नाही त्याचा अर्थ तुम्ही लाईव्ह नाहीत असं होतं. ओके, तर if you have any doubt then you can ask me. Now we shall stop here, and again I am going to tell you, you have to write the note on today's lecture and send its PDF copy. It is essential for all the students. Okay, now we shall stop here. Namaskar, goodbye.